Run that back, turbo.
You can get the biggest Chanel back in the store if you want it. I gave them the drill, they sucked it up, I got them on it. I bought a new paddock, I had to watch.
This is a super course for Trig, so this will only be a couple of lessons containing everything you need to know for Trig. So yeah, so today we're just gonna go over basics, starting with a triangle with 90 degrees, and then something called SOHCAHTOA. Right, so basically this side will be called the long leg. This side is the hypotenuse. The side, basically the diagonal is always going to be the hypotenuse, and then we'll call this the short side, the short leg. Alright, so this is one very, very key thing in Trig: hypotenuse, short leg, and long leg. So yeah, so let's get into this SOHCAHTOA. So basically, in a triangle, that's a bad triangle, let's redo that. In a triangle, you have these functions: the sine, cosine, and tangent. And these all have specific values in a triangle. And what we do in math is that we label this, or a given angle, if we don't know it, we call it theta. So this equals some angle, something x angle, and theta, this is how it's spelled, theta. Right? So it's just a random angle. So sine tells us that the opposite over the hypotenuse. I'll explain everything in detail in a bit. Cosine is, let's go ahead and write it out actually. So this is an acronym used for all of that. So adjacent over hypotenuse, and then tangent is opposite over adjacent. So basically, opposite from theta over here is going to be this, and this is our long leg, right? Long. Okay, and the hypotenuse is always this diagonal, doesn't change. And our adjacent side is always gonna be closest to the theta angle. That's right here. Okay, so this is ADJ, adjacent. Okay, so that's what they mean. So let's go ahead and put values to these. So if I have a triangle right here, that's my bad. Let's do that over again. Triangle, 90 degrees, always has to be 90. And let's say this is theta, and then these values are 3, 4, and 5. Okay, and we want to know the sine of theta, the cosine of theta, and the tangent of theta. So, using what we know, let's pick a different color. There we go. So the opposite will have to be 3 in respect to theta over here, because we know sine, it's right over here, sine equals opposite over hypotenuse. So we have it. So we have that opposite. Now we just put it over the hypotenuse. Hypotenuse never changes. So that's 5. So sine is 3 over 5. Now cosine is adjacent over hypotenuse. So we have our 5. We know that doesn't change ever. So we have 5. So adjacent, so closest to that angle, it's going to be 4, isn't it? Oh, it's always going to be the angle attached to the theta. So that's 4. And then tangent is equal to opposite over adjacent. So we found our opposite. Our opposite is already 3. So we have 3. Well, that's 3. Over the adjacent, we found that is 4. So these are all of our values that we found for sine, cosine, and tangent. Now one last thing. So an easy way to remember all of this is in the acronym SOHCAHTOA. And this is, so the S represents sine, the C represents cosine, and the T represents tangent. So the O is for opposite, and then the H is for hypotenuse, and then the C is for cosine, the A is for adjacent, and the H is for hypotenuse. And for tangent, the T is tangent, the O is opposite, and then the A is adjacent. So this is a really, really good way to remember all of these values using this acronym right here. So SOHCAHTOA. And this is going to be the foundation of trig. So it's basically revolved around SOHCAHTOA and what we learned over here, where how to find these values and understanding what each thing is. Alright, so that concludes our first beginning lesson in trig. Thank you.